Preparing for a Microsoft Cloud Solutions Architect interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a highly available web application on Microsoft Azure? I would begin with requirements for traffic, latency, compliance, recovery time objective, and recovery point objective. I would deploy stateless application instances across availability zones, place Azure Front Door and Application Gateway at the edge, and use autoscaling with health probes. Data would use zone-redundant services, such as Azure SQL Zone Redundancy, plus geo-replication for regional failure. Infrastructure would be deployed through Bicep, monitored with Azure Monitor, and regularly tested using documented failover procedures. While answering, cover Azure regions and availability zones, Azure Front Door, Application Gateway, load balancing, stateless application tiers, database redundancy, health probes, disaster recovery, and measurable availability targets. Question 2. When would you choose Azure App Service, Azure Container Apps, AKS, or Azure Functions? I choose App Service for conventional web APIs when managed deployment and simplicity matter most. Azure Functions fits event-driven, short-lived workloads where automatic scaling is valuable. Container Apps suits containerized microservices without requiring Kubernetes expertise, while AKS is appropriate when I need advanced orchestration, custom networking, or extensive Kubernetes ecosystem support. I avoid choosing AKS by default because its operational overhead is significant. The decision should follow workload and team requirements, not technology fashion. Make sure to compare operational responsibility, workload shape, scaling behavior, networking, portability, startup latency, orchestration complexity, team expertise, and cost across Azure's primary application hosting options. Question 3. How would you migrate a large on-premises application to Azure with minimal downtime? I would first inventory servers, dependencies, data flows, licensing, and performance baselines using Azure Migrate and application discovery tools. Then I would establish a secure landing zone, ExpressRoute or VPN connectivity, identity integration, and monitoring. For minimal downtime, I would replicate data continuously, test a pilot workload, validate application behavior, and schedule a controlled cutover during low traffic. I would retain rollback capability until business validation completes, then optimize sizing, resilience, and operating costs. In your answer, discuss discovery, dependency mapping, migration waves, Azure Migrate, landing zones, connectivity, data synchronization, testing, cutover strategy, rollback planning, and post-migration optimization. Question 4. How do you design identity and access management for an enterprise Azure environment? I would centralize workforce identity in Microsoft Entra ID, integrating on-premises directories when required. Applications should use managed identities rather than embedded secrets, and Azure resources should follow least privilege RBAC through groups and role assignments. Privileged identity management would provide just-in-time elevation, approvals, and auditability. Conditional access can enforce multi-factor authentication and device or location policies. I would also schedule access reviews and separate platform, security, operations, and application responsibilities. Be sure to mention Microsoft Entra ID, federation, managed identities, role-based access control, privileged identity management, conditional access, least privilege, separation of duties, and access reviews. Question 5. What Azure networking architecture would you recommend for a multi-tier enterprise application? I typically recommend a hub-and-spoke architecture. The hub contains shared services such as Azure Firewall, VPN or ExpressRoute gateways, DNS, and Bastion, while application workloads reside in isolated spoke virtual networks. Private endpoints keep PaaS traffic off the public internet, and network security groups provide subnet-level controls. User-defined routes force sensitive traffic through inspection points. Peering, address planning, and DNS resolution must be designed early because retrofitting connectivity is disruptive. Focus on hub and spoke topology, virtual networks, subnets, private endpoints, Azure Firewall, route tables, DNS, network security groups, centralized inspection, and connectivity to on-premises environments. Question 6. How would you secure secrets, certificates, and encryption keys in Azure? I would store secrets, certificates, and keys in Azure Key Vault, never in source code, images, or configuration files. Workloads would authenticate with managed identities, and access would use narrowly scoped RBAC. I would automate rotation, monitor access through Azure Monitor and Defender for cloud, and enable soft delete and purge protection. Customer-managed keys are justified for regulatory or ownership requirements, while HSM-backed keys provide stronger protection. Key lifecycle procedures should include backup and recovery testing. In your answer, cover Azure Key Vault, managed identities, secret rotation, customer-managed keys, HSM protection, certificate lifecycle management, access policies, RBAC, logging, and recovery safeguards. Question 7. How would you choose between Azure SQL Database, SQL Managed Instance, Cosmos DB, and Azure Database for PostgreSQL? I start with data access patterns rather than product preference. Azure SQL Database is ideal for cloud-native relational applications, while Managed Instance offers broader SQL Server compatibility and instance-level features. PostgreSQL is appropriate when PostgreSQL capabilities or portability matter. Cosmos DB fits globally distributed, low-latency workloads with flexible schemas and carefully designed partition keys. I would validate transaction boundaries, consistency, throughput, migration complexity, and cost using representative workloads before finalizing the platform. Discuss relational versus non-relational models, compatibility, transactions, consistency, partitioning, global distribution, operational control, migration effort, performance patterns, and licensing considerations. Question 8. How would you design disaster recovery for an Azure workload? Disaster recovery begins with business-defined RTO and RPO, not a preferred Azure feature. I would classify workloads, select zone or regional redundancy, and use services such as Azure Site Recovery, SQL failover groups, or geo-redundant storage where appropriate. Backups should be protected from accidental deletion and ransomware. A runbook would define dependency-aware failover, DNS changes, validation, and rollback. I would conduct scheduled recovery exercises and update the design from observed results. Make sure to cover business impact analysis, RTO, RPO, regional redundancy, Azure Site Recovery, database replication, backup immutability, failover sequencing, DNS, testing, and documented operational ownership. Question 9. How would you implement governance across multiple Azure subscriptions? I would organize subscriptions by business, environment, regulatory boundary, or operational ownership, then place them under management groups. Azure policy would enforce allowed regions, required tags, encryption, private connectivity, and approved SQUs. Budgets and cost alerts would provide financial control, while centralized logging and Defender for cloud improve security visibility. A landing zone should be delivered through reusable infrastructure code. Governance must enable teams through guardrails and exceptions, not create unmanaged approval bottlenecks. Cover management groups, Azure policy, subscription design, naming and tagging standards, budgets, resource locks, Defender for cloud, centralized logging, landing zones, and delegated ownership. Question 10. How do you design observability for distributed Azure applications? I would define service-level objectives first, then collect the signals needed to explain violations, metrics, structured logs, traces, and dependency telemetry. Application Insights and Azure Monitor can centralize this data in log analytics, with correlation IDs tracing requests across services. Alerts should identify actionable symptoms rather than every abnormal metric. Dashboards should serve operators and business stakeholders differently. I would integrate notifications with incident management and use post-incident reviews to improve instrumentation. In your answer, address Azure Monitor, Application Insights, Log Analytics, Distributed Tracing, Metrics, Structured Logs, Correlation IDs, Alert Quality, Dashboards, SLOs, and Incident Response Integration. Question 11. How would you optimize Azure cloud costs without harming reliability? I would establish ownership and tagging first so costs are visible by product and environment. Then I would right-size resources using utilization data, apply autoscaling, remove idle assets, and select appropriate storage and database tiers. Reservations or savings plans make sense for predictable baseline usage, while spot capacity can support interruptible workloads. I would protect reliability by defining minimum capacity and availability requirements. Monthly FinOps reviews should connect engineering changes with measurable cost and performance outcomes. Be sure to mention tagging, cost allocation, right-sizing, autoscaling, reservations, savings plans, storage tiers, shutdown schedules, architecture efficiency, budgets, and FinOps accountability. Question 12. How would you build a secure CI/CD platform for Azure workloads? I would use Azure DevOps or GitHub Actions with reusable pipeline templates and separate build, test, security, and deployment stages. Infrastructure would be managed through Bicep or Terraform, with plans reviewed before changes apply. Federated workload identity avoids long-lived service principal secrets. Pipelines would scan dependencies, containers, and templates, then require approvals for production. Blue-green or canary releases reduce risk, while immutable artifacts and deployment logs provide traceability and rollback capability. Focus on Azure DevOps or GitHub Actions, reusable pipelines, infrastructure as code, workload identity federation, secretless authentication, approvals, security scanning, deployment strategies, and auditability. Question 13. How would you design an event-driven integration solution using Azure services? I distinguish notifications, commands, and high-volume streams. Event Grid is suited to reactive events, Service Bus handles reliable commands and enterprise messaging, and Event Hubs supports telemetry streams. I would define schemas, correlation identifiers, retry policies, dead letter handling, and idempotent consumers. Ordering should be requested only where necessary because it limits scale. Consumers must checkpoint progress and expose lag metrics. The architecture should tolerate duplicate delivery rather than assuming exactly once processing. Discuss Event Grid, Service Bus, Event Hubs, delivery guarantees, ordering, retries, dead lettering, ID impotency, consumer scaling, schema management, and appropriate event selection. Question 14. How would you secure and govern an Azure Kubernetes service environment? I would use a private AKS cluster where exposure risk justifies it, integrate Microsoft Entra ID, and separate administrative and developer permissions through Kubernetes RBAC. Workload identity removes the need for stored cloud credentials. Network policies restrict pod communication, while admission controls enforce approved configurations and images. I would scan images, patch node pools, protect secrets with Key Vault integration, and monitor control plane and workload behavior. Cluster upgrades require staged testing and a supported version strategy. Cover cluster isolation, private clusters, Entra integration, Kubernetes RBAC, workload identities, network policies, admission controls, image security, node patching, secrets, and monitoring. Question 15. How would you integrate on-premises Active Directory with Microsoft Entra ID? I would assess identity sources, authentication requirements, application dependencies, and regulatory constraints before selecting Microsoft Entra Connect or Cloud Sync. Password hash synchronization is usually the simplest resilient option. Pass-through authentication or federation may be justified by specific requirements. I would limit synchronization scope, establish a verified domain, protect synchronization accounts, and plan for redundant agents. Conditional access and multi-factor authentication should be introduced carefully, with monitoring and rollback procedures for authentication failures. In your answer, explain synchronization, authentication choices, password hash synchronization, pass-through authentication, federation, hybrid identities, synchronization scope, resilience, and security monitoring. Question 16. How would you approach a zero-trust architecture for an Azure customer? I apply zero trust through 3 principles: verify explicitly, use least privilege, and assume breach. Identity becomes the primary control, supported by multi-factor authentication, device compliance, workload identities, and just-in-time administration. Network segmentation and private endpoints reduce unnecessary exposure, while Defender capabilities detect suspicious behavior. Data requires classification, encryption, and controlled access. I would prioritize high-risk paths first, measure policy impact, and evolve controls incrementally rather than disrupting every workload at once. Make sure to discuss verify explicitly, use least privilege, assume breach, strong identity, device compliance, segmentation, private access, continuous monitoring, data protection, and incremental adoption. Question 17. How would you design a scalable data platform on Azure for analytics? I would separate storage, processing, and serving layers. Data lake storage provides durable, economical raw and curated zones. Data Factory handles scheduled ingestion, while Event Hubs supports streaming. Databricks or Synapse can transform data using a medallion structure, and a governed serving layer supports reporting. I would partition by access patterns, catalog sensitive data, and apply private networking and managed identities. Batch processing is cheaper and simpler. Streaming is justified when business decisions require low latency. Discuss ingestion, Azure Data Lake Storage, Data Factory, Event Hubs, Databricks or Synapse, medallion architecture, governance, partitioning, security, and batch versus streaming trade-offs. Question 18. A production Azure service is experiencing latency spikes. How would you troubleshoot it? I would first establish scope, start time, affected requests, and the relevant slow. Azure Monitor and Application Insights would help correlate latency with deployments, dependency failures, CPU, memory, connection pools, database waits, or network errors. I would compare healthy and unhealthy instances, check autoscaling behavior, and inspect recent configuration changes. If a release is implicated, I would roll back or shift traffic while preserving evidence. After recovery, I would document the root cause and preventive action. Focus on symptom definition, recent changes, dependency mapping, distributed traces, saturation metrics, database behavior, networking, scaling signals, rollback decisions, and clear stakeholder communication. Question 19. How would you communicate and validate a cloud architecture with business and technical stakeholders? I begin by translating business goals into measurable requirements: availability, latency, compliance, growth, recovery, and budget. I use layered diagrams and architecture decision records so different audiences can follow the design and its trade-offs. Threat modeling and a cost estimate expose risks early. For uncertain choices, I build a focused proof of concept with acceptance criteria and representative load. I seek feedback from security, operations, developers, and business owners before finalizing a roadmap. Be sure to mention requirements discovery, architecture decision records, C4 or reference diagrams, trade-off analysis, threat modeling, proof of concept, cost estimates, and measurable acceptance criteria. Question 20. How would you modernize a monolithic application into Azure microservices? I would not split the monolith solely because microservices are popular. I would identify business boundaries, prioritize a painful or independently scalable capability, and use the strangler pattern to route new functionality around the existing system. Each extracted service should own its data, expose a clear API or event contract, and include observability and automated deployment. Azure Container Apps or AKS may host services depending on complexity. I would accept temporary duplication, but control it with explicit migration milestones. Discuss domain decomposition, strangler pattern, bounded contexts, data ownership, APIs and messaging, observability, incremental migration, platform selection, team boundaries, and operational trade-offs. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.